Hi, I'm Ma'am Ange. Today we are going to learn about mutually exclusive events in probability. So mutually exclusive events are two events if and only if they cannot occur at the same time. So it means that the two events are mutually exclusive when it cannot happen at the same time. So let's have an example for that. So flipping a coin, um, to get a head or a tail, it cannot happen at the same time. No, so you cannot turn left when you are turning right. And same goes with you cannot go forward when you are doing backward. So these are the things or events that cannot happen at the same time. So let's study the diagram, the Venn diagram. Which one shows mutually exclusive event? The first diagram or the second diagram? Yes, you're correct. The first diagram shows it is mutually exclusive. So when you say mutually exclusive, the two events cannot happen at the same time, therefore there is no intersection. And then if there is intersection, it means that it can happen at the same time with two events, therefore it is not mutually exclusive. So let's tell whether the two events are mutually exclusive or not. On the example, we have drawing a card or a club from a deck of playing cards. So is this mutually exclusive? Can you get a red card when it is a club? Yes, it cannot happen at the same time. Therefore, this is mutually exclusive. Another, getting a number multiple of 3 and divisible by 2 when a die is thrown. So which number in the die that is multiple of 3 and divisible by 2? Can we have the same? Can it happen, the multiple of 3 and divisible by 2 at the same time? Yes, because there is a number with that. Since it can happen, 6 is multiple of 3 and divisible by 2. It can happen at the same time. Therefore, these two events are not mutually exclusive. Another example, getting 3 heads or 3 tails when 3 coins are flipped. Can we have at the same time heads and tail? We cannot, so we have mutually exclusive events. Next, drawing a king or an ace from a deck of cards. So can we have an ace of king? Yes, we cannot. So therefore, it cannot happen at the same time. Therefore, this is mutually exclusive. Next, passing math or science. Can you pass both math and science? When it can happen both, therefore, this one is what? Yes, you're correct. This one now is not mutually exclusive. Because it can happen at the same time that you can pass math and then pass science. So, please try to remember if two events A and B are mutually exclusive, then the probability that either A or B occurs is the sum of their probabilities. Again, let me show it to you. So the probability of A or B is equal to the sum of their probabilities. Probability of A plus probability of B. So this one is for mutually exclusive events. And if not mutually exclusive, what are we going to do? So if not mutually exclusive, the probability of A or B, the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B, or this one, the probability of their intersection. To understand it better, let's have an example and solve some problems. So, example number 1. A card is chosen at random from a pack of a deck of playing cards. What is the probability of a king or a queen? So, in answering this problem, let's analyze it first if it is mutually exclusive. So, is king or queen mutually exclusive? Yes, it is. Because king and queen cannot happen at the same time, so it is mutually exclusive. Therefore, what are we going to use to get the probability? So we are going to use the probability of king or queen is equal to the probability of king plus the probability of queen. So let's analyze what is the probability of king. So in a deck of cards, we have 52 cards. And how many kings are there? 4. So the probability of king is 4 over 52. And then same goes with the queen. So the probability of the queen is 4 over 52. And we have to simplify it. It will become 8 over 52. Then we have to reduce our final answer. So this one is equal to 2 over 13. So the probability of getting a king or a queen is 2 over 13. Next example. A card is chosen at random from a pack of a deck of playing cards. What is the probability of a king or a heart? So let's try to analyze this. Is this mutually exclusive or not? Can we have a king of heart? Yes, we can have a king of heart. Therefore, it can happen at the same time. And so this problem is, or the events are not mutually exclusive. So the formula that we are going to use this time is probability of king or heart is equal to the probability of king plus the probability of a heart minus the probability that it is a king of hearts. So the probability of king is equal to 4 over 52. And then the probability of heart is 13 over 52 minus, we only have one king of hearts, so therefore 1 over 52. We simplify it, it will become 4 plus 13. 17 minus 1 is 16 over 52. And it will become, simplify it, 16 and 52, it is 4 over 13. So the probability of king or heart is 4 over 13. Next. Okay. There are 30 children in a class and they all have at least one cat or dog. 14 children have a cat and 19 children had a dog. What is the probability that that a child chosen at random from the class has both a cat or a dog? So when you say both already, it means it can happen at the same time. So this problem shows that it is not mutually exclusive. But then, to solve it properly, we can also use the Venn diagram. So to use the Venn diagram, we have this one, and then 30 minus 14, this one is 16 away. So we can have this one for the cat and this one for the dog. And so this one, 30, all in all children. So 30 minus 14 for with the cat. So this one is your cat. This is 14. So this part is 16. But then the one that has dog, children that has dog is 19. So we already have 16. So we can put here 3. So therefore it is 19. And then what about the one that has cat only? So when it has cat only, there is 14 for all cats. This one will become 11. There. And since we already can see the probability of the intersection of both cat and dog, therefore, the answer for the probability of it is cat or dog, no, wait. So this one is already the intersection. We are looking for the intersection. So this is intersection. The probability of cat intersection dog, so that is both cat and dog, is equal to 3 over 30. Or it is 1/10. So the probability of having a dog and a cat is 1/10. Another example. So this time, take a look at the problem. The probability that the student passes mathematics is 2/3. And the probability that he passes English is 4/9. If the probability that he will pass at least one subject is 4/5, what is the probability that he will pass both subjects? So let's try to analyze the given in this part. So this one again is not mutually exclusive because when you say both, so that means it is not mutually exclusive. So we can use the formula later and analyze it well. So the formula for not mutually exclusive again, for math or English, so math or English is equal to the probability of math plus the probability of English minus the probability of math and English. So that would be the intersection and English. There. So let's check the given. So math or English, this means that the probability that pass at least one subject. So this one is already 4/5 is equal to this one. Probability of math is already stated in the problem. So this one is 2/3. And the probability that it passes English, he passes English is 4/9. And this one, we are actually looking for this one, the probability for both subjects. So We are looking for this one. And then using the transposition, so we have to transfer this one since we are looking for math and English. We are looking for that one and substitute, transpose the values. So this one, 2/3 plus 4/9 minus 4/5. And to solve for that, we have to get the LCD. So least common denominator would be what? It is 45. Is it 45? There you go, 45. 45 divided by 3 is what? 45 divided by 3 is, yes, you're correct. It is 15. And 15 times 2 is 30. And then 45 divided by 9 is 5 times 4 is 20. And next, 45 divided by 5 is 9. 9 times 4 is 36. Next, we have to simplify this one. 30 plus 20 is 50 minus 36 is 14. 14 over 45. So this is, can we reduce this one? No, not anymore. So this one is our probability. 14 over 45. And that's it for mutually exclusive events in probability. Bye for now.